Red Craft. We invite several speakers to talk and share their insight to the community. Today, I'm really excited to introduce Mark Richard, who is, um, just give me a second. Today, I'm really excited to introduce Mark Richard, who is hands-on software architect. He has been software industry since 1983 and has significant experience and expertise in application integration, enterprise architectures, mostly within the financial service industry. He is founder of software developer to architect.com, a platform devoted for developers to become software architect. He is author of numerous technical books, including Software Architecture Hard Part, Fundamental of Software Architecture, and several books on microservices. Today, Mark will be sharing his insights on architecture modularity versus service granularity. With that said, Mark, welcome to the Software Craftspeople community. Over to you, Mark.
Oh, wonderful. Thank you so much. And I'm assuming everybody can see my screen okay. Is that correct? Or should I reshare?
Can you
We
try
were seeing
resharing
it
the
and
screen?
now it's gone.
Oh, okay. Let me just reshare my screen here and see there. Is that good?
Yes.
Yep.
Oh, perfect. Okay, so you should see the slides there. Excellent. Well, thank you so much for having me here to speak. I think I know I met some of you over at GIDS in Bangalore in early April when I was there speaking. And so I was asked if I could speak at some point. And this is a great time because I actually just got back from that trip. So it was a very, very long trip. So anyways, what I wanted to do today was to talk about modularity and granularity, but I'm going to add another dimension onto this, which is the things we do with regards to domain-driven design and also understanding domains in bounded contexts. And so I thought that was a good third dimension to this kind of talk. And so, well, one of the things which, let me get focus here on my screen again. And fantastic. So I am from the United States. I live in here in Boston. Thank you, by the way, so much for accommodating my time zone. I know it's getting late there, but it's very early here. So I think we kind of came together in a kind of collaborating to make sure that it was good for both of us. But what I really want to talk about is modularity versus granularity. And the big difference between these, which I'm going to show you in the next hour, is modularity is about the breaking apart of systems into different parts. But granularity is about the size of those pieces. And we'll be taking a look at each of those separately. But what I do have is a kind of a quote that I live by, and that is this: to embrace modularity, but beware of granularity. And what I mean by this quote is, in my experience, especially in today's world, which I'm going to show you the drivers for modularity, modularity is very important to achieving today's goals that we have in business. But where we get into trouble is actually the granularity piece, the size of those pieces, making services either too small or too big. And so I'm going to cover both of these topics in this session about why modularity is so important and critical, but also about granularity, how to get the right size of those pieces. So, and I just realized that I am going to have to take a 20-second break in a little while to go run downstairs and get some props that I forgot to set up. So I've got a really interesting demo to to show you here. But let's start our discussion about architectural modularity, and I want to link this to how we realize our domains and primary behaviors through modularity. Because what I have been experiencing, at least, and what I've seen, is that there is definitely a trend in taking our large legacy monolithic single deployment systems and breaking those apart into separate units of software. This is what is called modularity. Now, I want to investigate really the drivers, the why modularity is so necessary. And I want to start with this pocket knife right here. And well, I'll ask, of course, rhetorically, what does this knife do? And you ask, well, it cuts things. That's all it does. And this is a lot of times how our systems actually start out. They start out with a single purpose and very, very functional. But I have this knife and I like to trim my fingernails with it. But the problem is, because it's so sharp, I keep cutting the tips of my fingers off. And every time I do that, well, I have to wear Band-Aids, and it's really hard to type and to write code. So, you know, I'd like more features. And like our systems, customers want more features. Yeah. More function. And so I say, can you add a scissors or a nail file or something to this? And they're like, you know, that's a good idea. And like our systems, this knife starts to evolve into this knife. Now I don't have to buy so many Band-Aids. I've got scissors and a nail file. This is a lot more useful knife. But I look at this knife and it's simple, but I've got a lot more needs. I'd like a bottle opener, a can opener, maybe to open up some wine with a corkscrew and stuff. And can you add those features? And the company thinks it's a great idea. So, like our systems, customers want more. And this knife starts to grow into something that looks like this. So now I have a bottle opener, a can opener. I'm not sure what I would use the saw for, but these are bigger scissors. These are real scissors now. This is a lot more useful knife. But, you know, my favorite activity, everyone, is backpacking. I love hiking, whether it be hiking in the mountains or in the desert or in the forest. I love backpacking. And sometimes I go out for a week at a time. Well, this knife is okay, but I need a lot more features to make this useful for backpacking. I'd like a fish scale and a magnifying glass so I can actually see my maps and stuff. Can you add those features? And like our systems, it grows. Customers want more. And pretty soon, this knife evolves into something that looks like this. Now, this is actually the knife that I do own. However, it's no longer a pocket knife. This goes in my backpack. But look at how useful this is. There's all sorts of great tools on this. It's a lot more useful. And I'm a lot more happier about this because it's got so many features. And, well, guess what happens? Customers always want more features. And like our systems, this knife starts to grow into something that looks like this. Now, this is an actual knife. You could purchase this. I'm not sure what you would use it for because it's 7.5 kilograms in weight. I can't take this backpacking with me. I can't take this to the park. I can't even cut my fingernails with this. So you see what happens. Yeah, or yeah, try flying with that. I like that. This knife becomes useless, but look at all the features that this has available to it. It has, well, as a matter of fact, look what I can do, everybody. I can repair my car or my motorcycle with this. Does anybody have any problems with their teeth? Because I've got lots of dental tools. I can fix your teeth. I can pull your teeth. I've got some medical equipment over here. Here's my knife of knives in case I want to have just a lot of knives. You could see there's so many capabilities in this monolithic knife, but they're not really useful because it's too big. And you want to see something absolutely amazing, everyone. Now this is going to astound you. Are you ready? Are you ready? Check it out. This is still a knife. That is our original knife that we started this journey with, but it starts to grow over time. And what would make this knife more useful? Well, I'll tell you what would make it more useful is if I could take what's called a sawzall. It's a big saw that cuts through anything, including metal. And if I went like that, then I can have a knife to repair my bike or my motorcycle or my car. I can go and now I've got a knife to do dental work. Now I've got a knife to do medical equipment. There's my knife of knives. You see, if I could break this apart, then I could use it because I don't need all these features all the time. And this is, yeah, the knife actually does have a saw itself. So maybe I could use that to do this. I like that. But this is the problem that happens with monolithic systems. Now, what I want to do is this. So I need to take about 15 seconds to run over to my kitchen because I need to get a prop to show you another important reason why monolithic systems need to be broken apart. And so I'm not going away, but I'm going away for 15 seconds. So while I'm gone, just kind of ponder this knife in reflection to your existing system that you're working on. Maybe it's a large legacy system, but I will be right back in about 15 seconds. So hold on, everyone.
Like you have to use this knife like this. Maybe not like this. So yeah,
Your
knives then.
experience with a gun.
Okay, I'm back. I always forget to get the props for this particular demo, but it's a really important demo to kind of explain to business users why we should break our systems apart. And I want to show you this. So what I'm going to do is this. I'm going to stop sharing for a little bit because I want to do this demo, and then I'll reshare my slides. And so let me just stop sharing here for a minute. Okay, and you should be able to see me now. Is that correct? Yeah, perfect. Okay, because this isn't on the slides. This is just me. So here's how this works. So I'm holding up a clear glass. And by the way, everyone, I actually use this demo I'm going to show you at my client sites to explain why we should break apart our systems. So take a clear glass. You'll need two of them, but take a clear glass. Now the glass represents our server or our virtual machine, and it has threads, memory, CPU, all this kind of stuff. Well, the water that I'm going to pour into this actually represents the application, the system, or the product. Okay, and here's what happens. So as our systems grow, and you can kind of see, I'll hold this up a little bit, the water, now that water represents the monolithic system. And look what's happening. All of a sudden, as our company grows, as we get more customers, as we open up more stores, do you see the water's almost about to overflow the glass? Now, this is the largest virtual machine or server we can have. But this is the problem with monolithic systems, because if you look, it's consuming almost all of the threads, memory, and CPU of this machine. Now, what I'm proposing is this. If we can break apart our application, so we will need another server, and here it is. If I can break apart my system, now don't forget, the water is the application. And I can break it apart into two pieces or maybe even more. Do you see now in the water here, I've got a lot more room for growth for our company. And we can acquire a lot more customers. We can open more stores. We can acquire other businesses because now we've got more sustainability in our server. And this is one of the other drivers that I have experienced with large legacy monolithic systems is quite simply, they just get too big and they start consuming all of those threads, the memory, the CPU of our machines. And it doesn't matter how many machines we add that application to, because if I get a new server and try to scale that, I have the same problem I had before. It's filling up that second server. And so this is a really neat way of being able to demonstrate this need for breaking apart systems. So now we've kind of seen two different reasons. The knife, and let me go ahead and share again here. Entire screen, and there we go. There we go, beautiful. So the water analogy is a great visual to demonstrate to management or to business or somebody, a stakeholder, the fact that that single deployment unit is getting just too big to fit inside the machine, basically. So that's one reason. We've also seen the second reason. Let me just get my screen back over to here. There we go. And we saw another reason, which was, of course, that as we keep adding capabilities to these systems, they just simply get too big and too unusable. Okay, well, let me show you 5 other technical drivers for why modularity is so critical. The first of those out of the 5 is basically maintainability. Now, on the left-hand side, we have our monolithic system. That's a single deployment unit. A single assembly, a single ear file, that's a single WAR file, that sort of thing. On the right-hand side, we've broken it apart into separate independent services. These don't talk to one another. Now, we'll see what happens when they do, but right now they don't talk to one another. So maintainability is one of the first drivers. When we go to large monolithic systems, many times we don't even understand the code base. It's too big. And so consequently, I think these are the places to make and apply changes to add a new feature or to fix a bug. But I'm not really sure if that's all the places I need to change. And so it takes a long time, is my point with maintainability, to be able to add or maintain code. Whereas on the right-hand side, I've got a separately deployed unit of software. It already has a context. It's easy to understand that code base, and I know exactly where to apply my changes. And so maintainability becomes easier and faster. The second driver is testability. Now, this ability or capability is about 2 things. It's about the ease of testing, but also the completeness of testing. And when I make a change to our large legacy monolith here, what do I test? Well, I test my change, of course. What should I test? Well, responsibly, I should test the entire system because I'm not sure if I broke anything somewhere else, because that is the testing scope, the entire system. And maybe you've got 12,000 unit tests in your regression testing framework. But how long does it take to run all of those? Hours? Maybe days? So testability is about the ease of testing, but also the completeness of testing. And I'm not really sure I've tested 100% of everything. But if I make that same change over here in this service, I've got 23 test cases to run. I can get much better completeness of testing because my testing scope is smaller. Now, the third driver is deployability. Now, deployability of a system is about three things. It's about the ceremony involved with deploying our software. It's about the frequency in which we can deploy it, and also the risk when we deploy our software. And so if I make a change right here over in my legacy system, that entire system is the deployment unit. And so consequently, ceremony, let's see, what's the ceremony in deploying large monolithic systems? Well, let me tell you, the first thing we do is we have our code freeze on Thursday. And then Friday, we do all of our mock deployments and regression and stuff, and we try to get that right. And then on Saturday morning, Saturday morning at 2 a.m., we go to release our software, and of course, it breaks, and there goes my weekend. Yeah, that's welcome to IT. Yeah, and the frequency. What is this, weekly? Every 2 weeks? Maybe monthly deployments because it's so big? You know, if you think about the frequency, there's several problems when we start to say every 2 weeks or every month we deploy. First of all, there's so many changes that are happening in that single deployment that we're not really sure if maybe that last change broke something I changed a month ago that I tested. And so we get a lot higher risk. But what's the hardest thing we do as IT professionals, as developers? And the answer, deploying and releasing software. This is the hardest thing we do. We test and it works on our machines, but then when we go to deploy, either into a production environment or at client sites, something always seems to go wrong. And so think about that. If you're deploying monthly, you get 12 times a year to practice deploying software. And we all know to become really good at something, you have to practice. And so consequently, it actually works in reverse. So this is part of the problem with deployability. But if I make a change to a particular service right here, well, my deployment scope is only that service. And so frequency, well, in a lot of microservices ecosystems I work in, we deploy daily, everyone. And it's one change, not a group of changes. A lot less risk associated with that. And the ceremony, oh, it's typing in a command and waiting for green light, green light, green light, hot deploy. Yeah, a lot less ceremony as well. Okay, two more drivers. The first of those last two is scalability. Now, we all know, of course, oh, yes, we can all scale monoliths, just keep creating new instances of those. But the problem is, do you remember that knife I showed you? Think about that large knife. As our systems get bigger, if I wanted to take that hiking with me, I've got to take every one of those tools that I don't need with me. And that's the point about scalability, is I have to scale 100% of that functionality. Even though this is the only part that needs to scale right up here. But all of this comes with it, all of our reporting, maybe it's admin functionality. And the other problem is this, something called MTTS, mean time to start. What if I did need another instance of my monolithic application? How long does that take to start up a new instance to respond to increased load? Well, it's measured in minutes. 5 minutes to start it up, 10. I worked on a system about 8 years ago that took 15 minutes to become operational. Yeah. Whereas over here, if we look, we can scale in services at a function level. And our mean time to start is measured in milliseconds of time. It's not uncommon for most microservices to start up in 200 to 300 milliseconds. So this is another aspect of scalability, and that we start to see we can scale only those features and functions that we need to scale. All right. Well, the last driver is fault tolerance. Now, what I mean by fault tolerance is this. Let's say that I have some code that is spinning up some threads. Well, there's a weird condition where the loop that spins up threads doesn't close. So I keep spinning up threads and spinning up threads. Well, what's going to happen pretty much in about 10 or 15 seconds? I'm going to get an out of memory condition, and that entire monolith comes down. But what if I had that same code in this service right here, separately deployed unit of software, and that started spinning up too many threads, out of memory, fatal error? Well, I lost that function, but everything else is fully operational. That's a good way to illustrate and describe fault tolerance. Now we have something called MTTR, mean time to recovery. If a fatal error does occur, this is going to take minutes to start up. This is going to take milliseconds to start up. And so that's really the 5 drivers there. But what happens if this occurs? Oh, yes, all the services are talking to each other to get data that I need, to be able to execute some functionality that I don't have. Yeah, what happens here to maintainability? The ease in which I can modify the source code, it just completely goes away. How about testability? The ease of and completeness of testing. Yeah, I have to end up testing the entire ecosystem, and that goes away. Do you remember deployability? The frequency, the ease and risk. So I'd like to deploy that middle service right here. Oh, please don't. Please, can you wait till the weekend? Because you're going to bring everything down. Yeah, so we lose deployability. How about scalability? If I scale one of these services, I have to scale everybody. And finally, if that middle service fails, everything fails. So you can start to see modularity has a lot of benefits until we create something that looks like this. Now, what I'm going to show you in the second part that I'm going to start in a little bit here is how to avoid this kind of problem of all these services talking to one another, because generally that's not an issue of modularity. It's an issue of granularity. So let me show you one other aspect, because I usually get this question. But Mark, what about modular monoliths? So a modular monolith is a monolithic architecture style where we basically form our domains as modules, and it's a highly modular separated. Now it's still a single unit of software, but we've partitioned that architecture by domains. Well, does that have benefits because it is modular? I mean, when we talk about modularity, maybe it's not all about breaking apart systems. Well, let's answer the question, how important are distributed architectures? Because here we would have to agree, maintainability is pretty good. Because I've partitioned my modular monolith into modules or domains or subdomains, I know exactly where to go in my code to change something. Also, we get better testability because now if I change a module, depending on how much the modules talk to one another, that's generally the only thing I have to test. and I can have a relatively good level of confidence that I haven't broken anything. Okay, so those are two good benefits. But what about deployability? Because here I had to deploy all the code. Well, in the modular monolith, I have to do the same thing. So we really don't gain much from deployability, with the exception of a little bit less risk of breaking something, just a little bit. Well, how about scalability? Here I have to scale every bit of functionality. But the problem is a modular monolith is still a monolith. And so we have the same problems of scalability as well. And as a matter of fact, with fault tolerance, if I have a crash right here, those threads that are spinning up, that entire system goes down. Well, with the modular monolith, it doesn't matter which module breaks. It brings everything down. So isn't that interesting? To achieve what we really need to achieve in terms of all 7 of these drivers I've showed you, these 5 plus the knife plus the water glass, we do need distributed architectures. So that's the reason why modularity is so critical. And we can demonstrate that criticality by these kind of needs. Now, what I want to show you is I want to kind of look at domain design and architecture modularity. But when we start talking about domain-driven design and core domains, subdomains, bounded contexts, we start getting confused about the terminology. So what I'm going to say is, let's see how the primary behaviors of a system are realized through modularity. And what I'm going to use as an example is our use case from our book, Architecture, the Hard Parts. And that is called the SysOps Squad. This is a trouble ticket system where if customers have a problem, they can go to our website, enter a trouble ticket, and our experts in the field, that's called the SysOps Squad, will come to your home or office and fix your problem. Well, if we look at the primary behaviors, some of those domains or subdomains, whatever you want to call them, well, customers do need to register with the site. That's a large portion. That's a primary behavior of this system. Also, the ability to create tickets. That's the whole reason this system exists, is to create trouble tickets. But then we need to process those tickets. And so we have ticket processing. We also send out surveys and receive surveys and analyze those surveys. So we can think of that customer survey as a primary behavior of the system. And finally, ops reporting. We have a lot of reports that we generate through the system. Well, let's look at a few architecture styles that support modularity and see how these primary behaviors map. Because with a modular monolith, even though it's monolithic, we can realize those primary behaviors through the structure of our code. For example, notice that the higher level directory or namespace represents that primary behavior. In other words, customer registration. And then we further create another module for ticket creation. These modules that I'm creating here could be in a single code base, or they might even be jars or DLLs or gems or packages, whatever language you happen to be using. And you can see through the directory structure or the modularity, we can realize those primary behaviors even in a monolith. Well, service-based architecture is a distributed architecture where we can share a database, and we have what are called domain services. And there's 3 to 12. And we can share a user interface or typically break the user interface apart. But with this kind of architecture style, which is very common, by the way, we realize domains through each service. And so the idea here, each domain service, this is one single unit of software, represents all the functionality for that particular domain, all of registration, all of ticket processing, all of reporting, all in a single service. Then we go to the extreme, which is microservices. And here with microservices, we have single purpose functions deployed as separate units of software, each owning their own data. And so consequently with microservices, we start realizing our domains through groupings of services. And that's where we actually see those primary behaviors from a level of modularity within these three kind of architecture styles, all the way from monolith, kind of in the middle with service-based and domain services, all the way over to microservices. Typically, we would form a hybrid between service-based and microservices. All right, well, we're about halfway over with a little more than half, but let's actually take a look at service granularity now. So we talked about breaking apart our systems, but what size should those systems be? So here's a good question to ponder. How many services should there be in a single bounded context? And I think everybody kind of know the answer to that. Typically, we say one. One service and its data represents a physical bounded context. But what I'm going to show you for the rest of this session is kind of a fallacy of that, because it could be three services within a bounded context, all sharing the same data. And let me show you what I mean, because this is answering the question, well, if that's the case, we might have multiple services in a bounded context. So what's the right level of granularity? Well, it turns out to get granularity right, that's the size of the service, it involves two primary forces. The first are called granularity disintegrators. These are drivers that say you should break apart the service and make it smaller. And we balance that with granularity integrators. And that is, when should I maybe make my service bigger? So let me show you these. So the first out of them, I'm going to show you 5 disintegration drivers. In other words, breaking things apart even further and smaller and smaller. And the first of these has to do with what the service does. Its functionality. In other words, what we try to strive for in services is single responsibility principle, SRP. And that's the S part of solid principles from Robert Martin. Well, what we're looking for here is tight cohesion, the degree and manner to which everything relates in that service. Let's take a look at as notification service. So here we can notify our customers through one of 3 ways. We can text them, we can email customers, or we can send them postal letters, printed letters in the mail. I wonder, what's single responsibility? One service, which is notifying the customer, or is it 3 services? Now, when I do a poll, when I typically do this and ask people with a show of hands, you know what it always ends up with? Half of you would say make it a single service, and almost exactly half would say break it apart. This is single responsibility, says Mark. Well, it's my opinion, says Mohammed, that it should just be the act of sending a letter is single purpose. Do you see? It's highly subjective. That's the problem. But even if we did break it apart, this is still part of the context of notification, the subdomain, or even if you want to call it notification domain. But it's very, very, very subjective. This is the problem. Well, let me show you 4 other drivers that aren't subjective, that we can actually measure and demonstrate metrics. And the first of those 4 happens to be code volatility. In other words, the rate of change of source code, something I can actually measure. So let's go back to our notification service. Well, I can go into our Git repository and I can show you how often code changes. And the code in SMS and texting or email rarely change. But the code in the letter functionality changes pretty much every week. And the reason is because each letter that we send our customers is represented as a class file. And all the legal team love to change the wording all the time. Well, isn't this interesting? Because here's the problem. If I'm always changing postal letter, what do I have to test? Everything. I have to test SMS texting and email because I might have broken something. Yeah, I like that. Sure, things that change together stay together. I like that. But also that's my deployment scope. And if I don't have hot deployment, that means when I deploy, texting and email are down during that deployment. So I have a lot more risk of deployment. But if I break this apart into two separate services, this service rarely changes. It just always stays in production. And now letter is the only code I change. A lot quicker testing, more completeness of testing, less deployment risk, and easier changes. And so this is one driver which I can demonstrate to say, this area of code changes more than these others, and we can carve that out into a separate service. All right. The next is scalability and throughput. This is something else I can measure. So I go to our service and I measure, and here are the results. Do you realize we send 220,000 texts a minute, 500 emails, and on average, 1 letter a minute? Well, what does this service have to scale to? Oh, 220,000 a minute. Yikes. But I'm unnecessarily scaling email and postal letter. But there's another aspect of scalability here. Do you remember MTTS? Mean time to start? Well, it takes 200 milliseconds to start up this the functionality in texting. It takes 1800 for email because I have to start up the SMTP connection pools and instantiate a bunch of objects. But it takes 4,000 milliseconds to start up letter functionality. And because I connect to printers, because I am printing letters, I check the health of those printers. So my mean time to start is 6,000 milliseconds. But what if I broke that apart into 3 separate services? Now I can scale each independently. I have 10 instances here because that's where I need my scalability. 2 instances here, and only 1 instance of the letter service. Also, where do I need my scalability? SMS. If I needed some additional SMS functionality, my mean time to start is 200 milliseconds. That's pretty powerful. So this is another really great driver. Well, the other one happens to be fault tolerance. So let's say we've got a single service right here, and we have a problem with our SMTP connections. There seems to be a memory leak, and this is a third-party tool we're using for our third-party product for our connection pools. And so email keeps coming down. Well, guess what? When email comes down, the entire service comes down. But if I broke this apart, now when email fails, SMS and letter are running just fine. And also, what's my mean time to recovery? On a single service, my MTTR is 6,000 milliseconds. 6 seconds to bring up another service. SMS is not working meanwhile. People are trying to sign in, getting multi-factor authentication. Here, 1,800 to start up a new email service. That's pretty significant. And our last one is security. So let's say I've got a profile service with profile info and credit card info, but I want the credit card info to be secure. So I've got a lot of requests coming in here, and I secure those requests through code, because a bad request trying to get to the credit card functionality is already in that service. And by breaking it apart into two separate services, now that access control is outside of the context of source code. It's in a security layer or an API gateway layer that I can now prevent access. And so these are 5 main drivers for saying, yes, we should make the service smaller. But that's only half the story, everyone, because now we've got integration drivers. 3 drivers that say, not so fast. I think we should keep the service bigger. And let me show you those 3. The first are transactions. And so let's say that I chose to break up my profile service into profile and password, better access control to password functionality, and also code volatility. Well, what happens when I register a new customer? Well, the security and profile information encrypted come into the profile service. Profile info is mine. I do the inserts there, and I send the password info over to the password service, and it then does further encryption and tokenization. That's fine. But the problem is we don't have a database or ACID transaction. I can't do commits and rollbacks because the profile info is committed and then the password info is committed. And if there's a problem, now I'm in a distributed transaction world. And if we have to keep these always in sync, it means, well, we made them too fine-grained, and by combining them, we can now have that database transaction. And speaking of data, one of the biggest integration drivers, keeping services the same, in other words, bigger, are data dependencies. So here's our service. It's a single service with 3 functions, and it talks to these 6, it uses these 6 tables in a database. Well, we choose to say, oh, that should definitely be 3 different services. Okay, fine. But now we need to break up the data as well. Well, how should we break up the data and form new bounded contexts? The service or functionality that writes to the data is the owner. Okay, so function A writes to tables 1, 2, 4, and 6. So that means it owns it, but it also reads from table 5. Function B writes to table 3, but reads from 2 and 5. Function C writes to table 5, so it owns it, but also reads from 1, 2, and 3. So let's form the new bounded context, breaking apart the data as well. So 1, 2, 4, and 6 all go to service A. 3 goes to B, and 5 forms a nice bounded context with C. So that wasn't so hard. Oh, except wait a minute. Function A needs to read table 5. And function B, which is service B, needs 2 and 4, and 1, 2, and 3 for C. Well, I can't query that data directly anymore. I have to ask for that data because it's in a bounded context. This is how we get to that big spaghetti mess I showed you in modularity. So consequently, the way we avoid that is just to make this all one service again, because the data itself is highly coupled. Well, there's one last driver to show you, and that's workflow and choreography. So we have a single service here, and we say, oh, yeah, we all agree. Everyone agrees this should be 4 services. Okay. But the problem is now these are all highly semantically coupled through functionality. In other words, these really aren't independent functions, but they all need each other. So yesterday, customer goes in, makes a query, it returns it back in 1500 milliseconds. That was yesterday. Well, last night we released. And now that same customer goes in, and all of a sudden we get all this latency, network latency, data latency, processing latency, marshalling latency, security latency. And that 1500 millisecond request now takes 4500 milliseconds. Performance and responsiveness will be slower if we have to tie all these services back together. And the second problem we're going to have is reliability and consistency. Well, let's say the customer goes to make a request, and all of a sudden the last service here in the chain becomes non-responsive. What do? We tell the user there's an error, try again? Or what if these are all updates? I've made 3 updates and the last one failed. I can't issue a rollback. I have to try to compensate all 3 of those. I have to reverse all those transactions. And that's hard stuff. So these are the main drivers for bringing service apart. So when we come back to how many services in a bounded context, well, generally we start with the notion of one service, but you can see that we can change that granularity within a bounded context, assuming we keep the data the same. Once we start breaking up data, then each of these form a separate bounded context. But notice, if we choose to break apart the service into 3, but we share the data, that's the same physical bounded context. It's just a broader one. And so now we see, to really get granularity right, it really is about balancing disintegration drivers with the trade-off of integration drivers and back and forth. This is the hard part right here. But at least I showed you 5 drivers that say we should maybe break the service apart further or bring it back together. Sam Newman, an architect and a friend of mine, wrote a book about 9 years ago or so, Building Microservices. It was maybe about 10 years ago now. It was the very first book that ever came out on microservices. And Sam offered some really good advice. He said this: start out more coarse-grained, bigger with your services, and then move to more fine-grained as you learn more about them. That was great advice, but Sam never said what it meant to learn more about a service. This that you're seeing right here is what it means to learn about the service. Don't make services too small initially. Have a good reason to break them apart, because we see through those integration drivers, we have to break apart data. We start communicating between the services. We have worse performance. We have less scalability, less fault tolerance, and also less performance as well. So there's trade-offs to making services too small. So, all right. So that is kind of the discussion about modularity versus overall granularity of a service and how these two relate. And I'm going to come back and close with my quote. Embrace modularity. Modularity, as you saw, is very important to achieve the goals we want to achieve in terms of growth, in terms of testability, maintainability, scalability, fault tolerance. But just be careful about the size of those pieces. All right. So I do think we've got about 6 minutes before I have to actually leave to another class. But I'd be happy to entertain any sort of questions or discussion points that any of you have with regards to this.
Mark, have you really seen large monoliths being transformed into microservices?
Mm.
And the reason I asked that is just a little bit of context. We have worked with a lot of monoliths, and monoliths have these side effects. As they become successful, they're harder to scale. They're everything that you said, right? Harder to release. You're always running against the time. And as a result of that, every single person in the team is working very, very hard, like just
Yeah.
always, right? They don't have like a Slack. So the more a monolith gets used, it seems it loses the opportunity to it ever becoming more modular and breaking, like behaviorally, human organizational behavior does not support Slack to actually break it down. So have you actually seen it in big companies where a huge, large monolith actually gets broken down?
Oh, yes. As a matter of fact, both migrations and greenfields. This is basically what I've been doing for about the past 13 years. And so, yes, small applications, extremely large legacy systems. And I'm so happy, Sapan, you asked this question because this is a really great key takeaway here. Because when we say we're going to break apart a system into microservices, what's our first initial assumption? And that is every part of that monolith will become a microservice. And that's where we run into trouble. I'm going to show on my screen, I'm going to come back to service-based architecture. This was the architecture style where we have domain services and we share a database. The two biggest challenges, now there's about 100 challenges, but the two biggest challenges any team will ever face migrating monolithic systems are two things. The first is breaking apart data, and the second is getting the size of the service correct. Those are two of the by far biggest challenges any team will face. So in breaking those apart, I will share with you the secret sauce, the success of being able to do this, because the success is actually moving and migrating to this kind of architecture first. Forget microservices, but rather we start taking that monolithic system, we identify those primary behaviors. We can call them primary domains or core domains if you'd like. And we take those primary behaviors and we form them into their own coarse grained services. Notice we don't have to break apart the data yet. We can start logically separating the data, logically. But here's the reason why this is the key to migration success. And it's something I want all of you to remember. Not every portion of an application has to be microservices. That is such a key phrase, because when we went into our SysOps squad and identified our primary behaviors, which of these large coarse-grained domains really should be microservices? What do you think? Reporting? No, we don't need microservices there. Survey? No, why break that apart? There's really no reason. Processing? Maybe, yeah, that might have some reason. Creation? Definitely. That's where we want to break apart, because that's our customer-facing portion. We want high fault tolerance. We want high scalability. We want agility, that ability to respond quickly to change, and maybe even registration. So do you see, without going here first, it's a big challenge because we make everything a microservice and we break apart all the data, and we don't need to. So Sapan, that is really the key to your question is, yes, I have seen a lot of success. I would say about 30 to 35%, about a third of all efforts I've migrated or greenfield end up right here with service-based architecture. Yeah, so this is one of those things that we don't see right away, but doing this allows us now to be more effective and create these hybrid architectures. So yeah, fantastic question. And yes, I have seen this in action, well, for 13 years.
Thanks a lot, Mark.
Yeah, you bet. Yeah. Fantastic question. Listen, everyone, I'm so happy we ended on that question and that note, because it is really a great way of summarizing up these challenges of modularity and granularity in systems. I do have another class. I actually am supposed to be starting in about 5 minutes. So I do need to run off to that, but I do want to say thank you so much for inviting me to your community and being able to share some ideas and stuff. So very much appreciate it. So thank you.
Thank you, Mark, for spending some time with us. It was really insightful session. Really enjoyed it. And thank you for all the people who joined us today. For anyone who missed a part of the event, don't worry, we'll be uploading the recording on our YouTube channel. And also join our WhatsApp group community to keep updated about the community. Our next session will be by Michael Carducci on July 22nd. I will see you guys later. Thank you.
Okay, bye-bye, everyone, and thank you again so much. Keep the community strong.
Thank you.
Thank you.
Thank you.
Okay.
Thank you, Mark.
Thank you, everyone.
Thank you, Mark.
Bye-bye.
Thank you, Mark.